Now I'm going to show you how you can multiply mixed numbers. There's two ways that you can multiply mixed numbers. You can convert everything to improper fractions and multiply that way, or you can keep the numbers as mixed numbers and use a distributive property. So I'll show you both and kind of let you decide which one you like better. I definitely have one that I like better, but we'll see what you guys think. All right, so 3 1/4 times 4 2/3. What we're going to do is convert them over to improper fractions, so using our little popcorn method or whatever you want to call it. 4 times 3 is 12. 12 plus 1 is 13. So we're going to get 13 fourths. This is the fourths family here. Times, if we convert this one to an improper, 3 times 4 is 12, plus 2 more is 14. Thirds, because this one is thirds family. So remember the denominators will match what the little fraction part says. All right, so then to multiply fractions, you multiply straight across the top, straight across the bottom. So 13 times 14, if you multiply those together, you get 182. And 4 times 3 is 12. But you can see that those are both even. So we need to reduce it. You know, maybe if you're going to reduce, it would have been better not to get 182 at all and just leave this as 13 times 2 times 7 and make the bottom 2 times 2 times 3. That is always an option. Or you can take 182, just any kind of little calculator, 182 divided by 2, if you don't know what it is, it's 91. So that's 2 times 91, and 12 is 2 times 6. I know that. So this 2 over 2, those are going to cancel and give me a 1. So I get 91 sixths. But usually you want to answer in the same form of what you were given. So if you're given a problem as mixed numbers, you're probably going to want to answer as a mixed number. So now we're going to have to divide. I'm going to have to take 91, divide by 6. I get 15 in a little bit, right? So 15, and let's see. So this is what I'm doing here. 91 divided by 6. Goes in there 15 times. So 15 times 6 is going to be 90. And you see how you get that 1 remainder? What you do is that 1, that remainder, becomes the numerator of your little fraction, and this is sixths language. So 15 1/6 is how you would want to do that one. And yeah, you can get a little calculator to assist you. But when you change them to improper fractions, what happens is you end up having to deal with much larger numbers. And you might feel like you need the assistance of a calculator, right, for some of those little nitpicky things. So it would be nice if we didn't have to worry about having a calculator, and that's one of the benefits of using the distributive property. So let's work the problem this way and see how it's going to break the problem down into a little bit easier bites, little small bite-size problems, which I think are a little bit easier to handle. So I'm going back and rewriting 3 1/4 as 3 plus 1/4, because that's what it is. It's 3 plus an additional 1/4. And then I'm writing 4 2/3 as 4 plus 2/3. And see how you have like 2 little pieces times 2 little pieces? We're going to be able to use FOIL to multiply these. So I'm going to start with my 3 here. And I've got it. The 3 and the 1/4 both have to get distributed to the 4 and the 2/3. Everybody's got to pair up at some point. So 3 times 4, and then 3 times 2/3. That's what we're going to do for this first part. So 3 times 4 plus 3 times 2/3. That's the green part, right? That's my green distributing. All right, now let me distribute my 1/4. The 1/4 is going to get distributed to the 4 and also to the 2/3. So I'm going to have 1/4 times 4, and then 1/4 times 2/3. Okay, and that's going to be my purple distributing. So if you have a little two pieces times 2 pieces, you're going to get 4 pieces, because 2 times 2 is 4. So you have 2 that are green, 2 that are purple. And these are 4 small little problems that are much easier to do, like in your head. So 3 times 4, that's 12. When you multiply 3 times 2/3, what's going to happen is you're going to get 6 on the top, but you have 3 on the bottom. and 3 divides into 6. So actually what you could do is just cancel them right here off the bat. Those 3's will cancel, and you just end up with 2. So that's nice. And then here, 1/4 times 4, that's like a 4 over 1. Same thing's going to happen. Those 4's are going to cancel. You just get 1. So that's nice. And then for this last little piece, you're going to have to multiply straight across the top and straight across the bottom. So that's going to be 2/12. So add up what you have. 12, 13, 14, 15, and 2/12. The only kicker is you need to make sure that you reduce this guy. That little fraction should be reduced. So it would be 15 and 1/6. So you get the same answer, right? Both methods yield the exact same answer. It's just about which one is easier. I like this one better. It looks like it's more work, but actually the pieces are smaller. To me, once we get up into numbers like 182, I'm like, oh man, like I want to bail. The numbers are too big, right? So I have a tendency to do it this way. And maybe you didn't even realize you could do it this way, but you can. And if you're teaching this to kids, I think actually part B, that's the easier way to go, assuming that they understand the distributive property. So kind of tied into this, let's do one more problem and see if we can figure out what the student error is. So it says, a student suggests that to multiply 2.5 and 3 1/4, you multiply the whole number parts, multiply the fraction parts, and add the results. Do we agree? So let's see if we can figure out what the student is saying. They're saying multiply the whole number parts. So the whole number parts would be the 2 and the 3. So I think they're saying you multiply 2 times 3. And then they're saying you multiply the fraction parts. So here's the fraction parts. They're saying we multiply 1/2 times 1/4, and it says and add the results. So that, and that, I mean, it makes sense. It's kind of like trying to multiply the parts that look the same. So multiplying the whole numbers, multiplying the fractions, and then adding them together. So what they're saying is that this is 6 plus 1/8. They would be saying the answer is 6 1/8. And so based off what we just did, do you think that this is the correct way to do it? It seems reasonable. But do we agree with the student? You should not. Don't agree with the student because that's not actually the right answer. So the reason why is they only did half the work. Look, they got 1, 2 pieces, right? 2. Didn't we say that 2 times 2 is 4? You should have 4 pieces. They only have 2 pieces. So let's see the correct way to do this. You would take 2 plus 1/2 and you would multiply by 3 plus 1/4. So let's do it again here, right? We're going to get the distributive property in here. Going to distribute like that. So we've got 2 times 3, 2 times 1/4. Right, that's the green parts. Let me just underline them so we can keep it all straight. And then we have the 1/2 that we have to distribute, the purple part. So we have 1/2 times 3 and 1/2 times 1/4. Right? 2 by 2 is 4, right? So which ones did the student get? Well, the student got that one, the first one, and they got the last one. The problem was the student forgot all of this part in the middle, right? So I'll say this. Student missed. I don't know if y'all can read that. My pen is not wanting to write very good. The student missed those 2 pieces in the middle. So really this should be 6 plus, hold on, let me switch pens since my pen is wanting to be snarky here. Two times 1/4 would be 2/4. That's the same thing as 1/2. And then we have 1/2 times 3 would be 3/2. And then 1/2 times 1/4, That is 1/8. So they had the 6 and they had the 1/8. They just missed this part in the middle. So let's see. If we're going to add these together, we need 8 as a common denominator, right? Well, these are halves, but eventually it's going to have to be added to the 8. So let's just go ahead and get a common denominator here of 8 for all of these. Now the last one has already got the 8. So let's talk about what would we have to multiply 4 by to make it an 8. You'd have to multiply by 2. And the 2, to make it an 8, you'd have to multiply by 4. So we have 4/8, 12/8, and 1/8. That's our common denominator there. So that would be 12 plus 4 plus 1. That would be 17/8. But the problem is, you see how that's improper? You're not allowed to have an improper piece inside your mixed number. So if we take 17/8, how many times does 8 go into 17? It goes in there twice with 1 left over. So this is 6 plus 2 and 1/8, which would be 8 and 1/8. So that's actually what the correct answer is. The students said it was 6 and 1/8, so they were off by quite a bit. But regardless, now you've seen a whole nother example worked, but the point is it's 4 pieces, and so you've got to remember to have all 4 of those in there. And then the rest of it is just, adding up your fractions and making sure that everything is in like reduced form.